Hello, this video is regarding a state-of-the-art clinical text natural language processing technology that we have developed. Now, as we know that a lot of medical information is um, present in clinical notes, a lot of paper, faxes, etc. Um, a lot of this information about, for example, the symptoms of the patient, the comorbidities, any past drug use, alcohol use, smoking status, etc., is locked up in these clinical texts. The the CPT and ICD codes are primarily for billing, but what that leaves behind is a wealth of information that is not analyzed, but remains locked up in these clinical notes. Just to emphasize, clinical or any natural language processing is basically a sub area of artificial intelligence, and it basically involves computers to understand not only the English language, but also on top of it, training computers to understand medical terminologies and medical knowledge itself. So here is a sample fake note, clinical note that might accompany a DWC-RFA or a PR1 type report. This is a work comp uh, type of a clinical note. So here we have an injured worker who works as a shelf stocker and has suffered an injury during lifting. Um, the clinician has made certain diagnoses and requested certain procedures and has also prescribed a medication. Let's go ahead and analyze this text. So what we are going to show today is the raw data. This is not how the system or your end users would interact with the system. We would take this raw data and build a custom application for the very particular sort of situation or application that you desire. This information can be also exposed using an API. So they would, in some applications, there wouldn't be a user interface. It would be just an API. There's a lot of raw data that we parse out of a given clinical text. So I'm going to go through those in detail now. So right off the bat, one of the applications we can see of this technology is that it has identified PHI information. And so one potential application could be to scrub a note of any PHI information. And we can build that technology to actually replace, for example, the names and these terms uh, with um, uh, with some anonymizing text. The system, whenever it sees, for example, a body part being mentioned, um, it can decipher, for example, that this is a body part, and it will flag that as a system organ site. And what we have here on the right hand side are some further disambiguation SNOMED code. So for example, when we say lumbar spine, if this was built as a one of the possible applications could be to let the clinician further specify exactly what they meant. So we could probably uh, give them a little sort of a autocomplete or a drop down, and we would actually store the exact SNOMED code of what lumbar spine them really meant. Um, the NLP technology is smart enough to understand, for example, when it sees like the word back, it can understand whether we are referring to the back of a patient or the back of a pickup truck. So it's not simply doing like a word by word comparison to body parts. Is actually smart enough to understand uh, if for example, the word back um, refers to the patient's back or a back of something else, or the legs of a table versus legs of a patient. And we'll see more examples of that in upcoming here. Um, the There was a lumbar spine injury, and notice that we are not flagging it with the symptom. It's actually a diagnosis. So the clinician actually has sort of agreed that we have an injury of the lumbar spine. Again, the 30th of June is a PHI date, but further, the computer sees that the lumbar spine injury took place on the 30th of June. It actually has flagged it over here. So um, it's actually making able to make relationships between dates and other time events and what they pertain to. So here it's clearly figured out that the lumbar spine injury took place on 30th of June. Um, for example, here we have figured out that the axial low back pain uh, is a diagnosis that the clinician is sort of agreeing with. So let's actually see in the text. The clinician is saying the patient has had axial low back pain since the above mentioned incident. And so when um, for example, the technology sees um, a medical condition, but it has other modifiers to that medical condition. For example, there is a back pain, but it has the direction is axial and it's on the low back pain. It can actually sort of help us further classify where that back pain is, and it's of a type symptom and also a diagnosis. Um, Similarly, here's an example where I was saying, it knows when the word back refers to a patient's back versus something else. So here we have figured out that in this clinical text, uh, back is a body part that probably is involved in this claim. Um, we are talking about physical therapy. The clinician made a comment here. So far, conservative care, including physical therapy and acupuncture, have not restored patient to pre-injury status. So the computer sees that and kind of flags that the patient has or is undergoing physical therapy and acupuncture. And patient has pain as a symptom. And the patient uh, we are basically saying here he has decreased pain with rest. So this is an example where the NLP technology finds uh, when it sees decreased pain, it's trying to identify as a medical condition. So this is an example where it has made a genuine mistake. So it's not really a medical condition. Now here on the next piece, where we say he has no radicular symptoms. So this is one of the um, very important sort of technological leaps that um, we have recently made in artificial intelligence with our technology is called negation, because there's many ways to say something is not there. For example, the clinician might say there's no indication of radicular symptoms. I find no evidence of radicular symptoms. There's many ways of saying no. Something does not exist. And so computers have historically had a lot of trouble understanding negation, whereas our technology here clearly understands negation. It has figured out there's no mention of radicular symptoms or bowel or bladder dysfunction. There is no tingling. And not only is there no tingling, it actually figures out there's no tingling in the legs. There's no numbness in the legs, and there's no weakness in the legs. Further, um, legs was identified as a system organ site. It's not really relevant to the claim at hand, but it still pulls out that information. Uh, there's a no the patient is denying any previous injury to the low back, and um, that's that part of the note. And no patient also denies disability to the low back previously. So this some of this information is very could be important for like insurance companies to store in their databases. So the patient is making some denials for certain body parts um, in this encounter. If on a subsequent encounter some of these claims were found to be sort of contradictory, there would have to be kind of a flag or an investigation. So a lot of this information, like I said, was locked up in a clinical text, and now we can actually analyze it and surface it. I also want to mention on the right hand side, you'll see these numbers. These numbers are SNOMED codes. So not only are we pulling out information about a given diagnosis, but we are actually pulling out or suggesting SNOMED codes, as well as then also suggesting the ICD codes. These will be more relevant when we go down to the diagnosis area. So let's keep going. Uh, Patient is denying high blood pressure. The patient is also denying previous diabetes and no cardiac or pulmonary issues, no renal issues. Uh, Now here we get down to the diagnosis area. So so the clinician has made this as a diagnosis. Unfortunately, we couldn't really find a code for this, but for this diagnosis, we actually have a SNOMED code as well as a ICD-10 code, and so um, this is also kind of important for example, medical transcriptionists, where we can make suggestions, relevant suggestions as to what the diagnosis code should be, rather than them trying to do a search for medical terminology. We can simply right away suggest that, hey, this is the right code. Or in case of more than one, at least we can give them a menu of uh, the most relevant diagnosis codes that they can then transcribe. Disc is picked up as a body part. Uh, Here's another diagnosis that the clinician has made, disc degeneration. Uh, so we can then, if this was a UI based application, we'd ask the clinician to further maybe disambiguate it, disc generation of what type, and for every one of these diagnosis, we are making suggestions for what the SNOMED code is, but more importantly, depending on the application, if this was a work comp, then we are really interested in the ICD-10 codes. Again, disc is a body part. Disc herniation, that's another diagnosis that we have identified, and we are then suggesting what kind of disc herniation should be selected. Similarly, we keep going. Now we come down to the procedures. Now here, when the NLP system sees a procedure being mentioned, it can classify it as a procedure, and we suggest SNOMED codes. In this case, we can also suggest CPT codes. The mapping of SNOMED to CPT is a paid service, and if a client desires to map SNOMED codes to CPT, that can be done as well, just like we are doing SNOMED to ICD codes. So we have procedures here. All three procedures are being sort of correctly flagged, and we are suggesting the codes for these. Let's go down to the medication. So here, when the system sees a medication and some modifiers to that medication prescription, for example, here we have a prescription for hydrocodone. It actually figured out that 100 milligrams is the dosage, 3 times a day is the frequency, and the route is oral. So this kind of parsing of the clinical text is very important to make those relationships between what is being said in the clinical text. So I hope this was a helpful introduction to our technology. Like I said, this is the raw data. We would have to sort of put together a very custom application to take this raw data and make a meaningful, useful application for your particular needs. Please let us know. We'd be happy to set up further demos for you and get your feedback. Thank you very much.